Hello everyone, welcome back to JT classes. I am Kansasoni. In the last videos we have discussed about location of roots. We have discussed the category 1 when the number k lies in between the roots and the condition was a into f of k is less than 0. Then we moved forward with the second condition, that was the number k lies outside the roots and how to throw the number out of the roots. The condition 1, d is greater than equal to 0, and the condition 2, a into f of k is greater than 0. After that we moved forward with the third condition, that was my number k lies outside the roots, but this time in a particular direction, like both the roots are greater than some number or both the roots are smaller than some number. Then what we are doing, first we have to throw k out of the roots. How we will do? D greater than equal to 0 and a into f of k greater than 0. After that we will just check out minus b by 2a, and according to that we will see if both the roots are greater than k, then k has to be less than minus b by 2a. If both the roots are smaller than k, then k has to be greater than minus b by 2a. So up to there we discussed. In today's video we will be discussing the next condition, which is if exactly one root lies in between k1 and k2. Okay, let's discuss the next category. When exactly one root lies between the real numbers k1 and k2. We know that if my a is positive, then the graph will be upwards, and if a is negative, then the graph will be downwards. If a is positive, suppose the roots are alpha and beta, then we can say that alpha lies in between k1 and k2. From the first one, can I say f of k1 is positive? Since what can we see, that f of k1 positive. And what about f of k2? F of k2 is negative. So we will say f of k1 is positive and f of k2 is negative. Coming to the second condition. In the second condition, can I say f of k1 is negative and f of k2 is positive? Now from the first one, can I conclude that from these two we can say f of k1 into f of k2 is negative, and from the second one also we can conclude that f of k1 into f of k2 is negative. So what can we say, that if exactly one root lies in between k1 and k2, then the condition will be, the first condition will be d is greater than 0. That is obvious, the root has to exist at the first two distinct roots, so d is greater than 0. And then the second condition will be f of k1 into f of k2 has to be negative. Thank you.